This is a circuits problem. It reads, the circuit in figure 1 contains a low resistance mechanical battery that exerts a non-coulomb force to move electrons through the battery with negligible internal resistance. The end plates of the battery are very large compared to the distance 0.1 L between the plates. Two thin nichrome wires of length L and cross-sectional area A connect the battery to a thick nichrome wire of length 0.6 L and cross-sectional area 4A. The electron mobility of the nichrome is U, and there are N mobile electrons per cubic meter in the nichrome. So A wants us to draw electric fields at each location marked by X, and we can use this relationship here because we know N and U are the same. So if A is increasing, then E has to be decreasing. So in the thick wire, that's why the electric field is much smaller than in the thinner wire. But as you can see in the thinner wire, the electric field does remain constant. And at location B here, there is a much greater electric field due to the battery. And it's also in the opposite direction because it's due to these plates. So it's going from positive to negative inside the plate. And outside, due to the wires, it's going to move around this way, going from this positive plate to that negative plate. B says calculate the number of electrons that leave the battery every second. So we use the node rule, and we know that the second electric field has the 4A area, and N and U can be canceled out because they're the same. And then using the loop rule, we know that the change in the potential all the way around is going to be 0. So this is the EMF, the force times 0.1, which is the distance between those two plates, divided by E, which is just constant. And we subtract the electric field times the length all the way around, starting here and going all the way around. And by knowing this relationship, we can manipulate it to find E2. And we plug that in to here and solve for E1 that way. And now we can know this relationship for the electron current. And the last question says calculate the magnitude of the electric field between the plates of the battery. So again, using the loop rule, we know that the change in potential all the way around the loop has to equal 0. So we know the electric field due to the battery times its distance, and just do the same all the way around. And we again use the expression we found here earlier, which we also used here for E2. And we just solve for the electric field due to the battery